Hey everybody, it's Chris from the Droning Company here with my new friend James Honicker from Ghost Robotics. He is a software engineer there. Jimmy, tell me a little bit about what you do within Ghost Robotics.
So my role is a field application engineer. So my primary role in the company is to go out into the field, integrate with our customers, and design new payloads or integrate payloads to accomplish missions across the company. So I'll go travel across the country to different bases or facilities between private and the DoD sector, and I'll make sure that the robots are working, teach them how to use the robot, integrate whatever sensor packages they have on site, and put together essentially the solution that they need.
Excellent, excellent. Now, Ghost Robotics, tell me a little bit about that company, how it got started, and what it is your initiatives are as a company, what kind of technology you're providing for both the commercial and enterprise sectors.
Sure. So the company was founded in 5 or 6 years ago out of the doctoral thesis of two UPenn graduates who studied in the GRASP lab. They had the idea of robots, like humans, should be able to walk without having to see. Most of the legged robots in the industry now are previously relied on depth cameras to see the ground plane in order to know how to step their feet. And they thought, hey, humans can shut their eyes and walk, so can animals, so why shouldn't robots be able to do that? And they designed the basis of the locomotion of the robot around that idea. It doesn't rely on any of its cameras, first and foremost, to balance and move across the ground. And because of that, we're able to excel in a lot of areas that our competitors and other robots in the industry can't, such as like harsh, rugged terrain where you have rain, sleet, dust, sand, mud, things that would clog up sensor systems. We don't need that at all, so we can continue to operate and succeed.
That's excellent. That's excellent. Now, that brings me to my next question. We see this guy back here, and very interesting, and I was talking with Christina a little earlier. It seems like something you could get attached to because it's so lifelike. Now tell us a little bit about some applications for this technology, what its strengths and weaknesses might be, what it's capable of in the field.
Sure. So there's two main fields of application. So you have the autonomous application, and then we'll call it the tactical application. So on the autonomous side, you have a lot of companies looking to do persistent security. So essentially the robot can be autonomously navigate around fence lines or do perimeter patrolling or around whatever route you want to do to report on people it sees or vehicles or to check sensors or to do anything with the sensor packages you equip on it. And it can just continue to do that forever as it goes out, runs its route, comes back to its home base, docks, charges, and then another dog goes out. And then you have the more tactical use case, which is like law enforcement, EOD, sending the robot in with a manned controller into dangerous situations that you don't want to send a human into, whether it's a bomb threat or a hostage situation or into a high power area to do surveillance or to check on something that is too dangerous for a human to go into. Or even something as dirty like going into a sewer. You can send the robot in, it can map the entire sewer system out, and no more, you don't have to worry about a human going down into the sewer, catching a disease or anything like that.
Yeah, absolutely. So the one thing I really want to see, and Christina can help us out in the background, I'll bring you out of frame. Let's see this thing in action, sort of. So come on over here so we can talk a little bit about it. Let's see what some of this is in action. And one of the things that I saw earlier was its ability to balance and adjust to external stimuli. So Christina was able to grab it and drag it around. I'd love to see it in motion and sort of tell us what's going on when it does that.
Yeah, so at all times, the robot is running a very, very fast control loop that essentially takes impulses from all of its legs, its IMU, and what all the feet are seeing, and makes adjustments in real time to keep itself upright. Okay. And in the event that the robot would flip, it actually can invert all of its legs and operate it completely upside down.
Wow.
So, and when it does that, it'll flip all the camera feeds, it'll flip all the controls. So from a user perspective, you have no idea anything's different. And if you have a special payload that you need to stay upright on top of the robot, it can roll itself back over to right itself, if that's the case you need to happen.
Gotcha. Excellent. Now, if somebody wants to learn a little bit more about Ghost Robotics, about this particular product in general, where can they find out the most information?
So if you search our website, if you just Google Ghost Robotics, our website will pop up. We have a lot of videos and information posted on LinkedIn and other social media sites. And there's some YouTube content, but most of it is through our website and LinkedIn, I think, is the best place to find our information.
Excellent. Jimmy, really appreciate your time. Thank you so much. This has been awesome. Thank you.